if I have to talk to you again, I'm going to ask you to leave because I've now talked to you twice about it and you're being disrespectful. So we just said we're going to put 40 here because her father is 40 years old. So Marcy's father is 4 years older than, so we're adding the 4 to 3 times her age. Yep, all of our extra work since I don't know when has always been up on that tall desk. So if you ever need an extra copy of something, you might have to look for it. You guys ever play hide and seek when you're little? Did you just give up? Yeah. All right. Sorry, I forgot. You guys can't handle one side remark. All right. Mr. Sloan paid $10 for parking and $12 each. Each tells us that's going to be a rate. So Allison, I need you right here. Each tells us it's going to be a rate, which means we're multiplying something. $12 for each. So 12 times the number of tickets. So if he spent $70 in all, we know it's equal to what? So we can fill this in. We know this is equal to $70. What am I going to put in this first blank here? Yeah, I would put 10 here. We're not multiplying it by anything, right? It's just how much parking costs. And then we just said $12 is going to be our rate. So $12 times each ticket. All right, I'm guessing number 3, yes, is the same as number 1. So hopefully you've already done this and these are review. So Easton went to a concert with some of his friends. The tickets cost $29.50 each. That tells us it's going to be our rate. So that tells us our rate is our coefficient. Do you remember that word? That's the number in front of our letter. So that's what we're multiplying by however many tickets there are, right? And they spent a total of $15 on parking. So this and this are essentially the same question, same problem, but with different numbers. So we're trying to figure out how many people were instead of how many tickets this time. But if we figure out how many people, that's how many tickets we had to purchase. So the tickets cost this $29.50. So each, we're looking for $29.50 times P. I see 2 of those here. Are we adding the $15 parking fee on it or subtracting the $15? We're adding it to equal our total. So we're going to go with this C here, we'll call it. All right, now we have to answer the question, right? We want to know how many people P went to the concert. So we're going to rewrite our equation. 29.5P plus 15 is equal to 133. So the first thing we have to do is add or subtract. What are we adding or subtracting? 15. Am I adding or subtracting it? You got it. So if I added it, it would be 30 and it wouldn't get rid of it. So in order to get rid of it, I have to subtract it from both sides. Elson, if you're not going to be helpful, I need you to be quiet. So I'm going to bring this part down. That does turn to 0 and goes away. So 133 minus 15 is 118. And then I'm dividing by 29.5. That seems reasonable, right? We know 25 would go into 100 4 times. So 118 divided by 29.5 per ticket gives us 4 people. So P is equal to 4. So that is our answer, 4 people. Okay? So not only do you need to know how to solve the equation like that with 2 steps, you have to know how to write the equation in some real world stuff, right? All right. We've done this one too. Ishi bought us $6.95 canvas and 8 tubes of paint. I think this one was tricking some of you. You were mixing up what we needed to multiply by the tubes of paint. So if each tube cost C amount of paint, we would be saying 8 times C to how much we're paying, right? So we can choose from the top 2. Are we adding it with the canvas cost, or are we subtracting it from the canvas? We would add it because it's a total amount. We're paying for the canvas and for the tubes of paint. So now we simply have to solve $6.95 plus 8C equals 24.95. So then you would solve by taking the opposite of $6.95 from both sides. That leaves me with 8C is equal to 24 minus 6. Because 24 minus 6 is 18. All right, so then we would divide both by 8. It is likely that we get a decimal, right, when we're talking money. So 18 divided by 8 is $2.25. Does that seem reasonable for a tube of paint? Yeah. All right, remember that per tells us it's a rate, which is going to be our coefficient. This is going to be our constant. That's what's added to it. We know it's added to it because it literally says plus here. And the total is, this is our equal sign. So we want 1.5 by itself. So we have 2 choices here. One has 10 times M. I'm not sure where that's coming from. So that's a big no. The second one is that 60 cents per mile. So 6/10 times the number of miles. So now we just have to solve 1.5 plus 0.6 M is equal to 13.5. What do you do first? Yes, good. We got to get rid of the constant. So that leaves us with 6/10 M is equal to 12. So we have to divide both sides by what? 6/10. 0.6. Is it 2/10? I'm not sure. Decimals throw me off sometimes. So 12 divided by 0.6 is 20. It was the other way around. So 20 miles is our answer. Figured out how far they went by how much they paid. At the market, Meyer buys a bunch of bananas for, there's that per, that tells us our rate, which means it's going to be our coefficient, and a frozen pizza. This is a constant price. There's just one of these. So the total for his purchase, here's our was, is equal to that $6.94. So that's already there. Our constant is that $4.99, so it's not the bottom two. So knowing that, are we adding the bananas and frozen pizza cost together or subtracting them? We got to add them because that's the total price. So then we're just going to use that equation, right? So we have 65 hundredths times P. We're trying to figure out how many pounds of bananas equal to $6.94. We got to get rid of the constant. So we're going to subtract it from both sides. Feel free to use your calculator. 694 minus 4.99, $1.95. So they're spending $1.95 on bananas. If the bananas are 65 cents per pound, how many pounds of bananas? So I'm dividing both sides by the coefficient, by the number in front. So I'm dividing by 0.65. Tells us 3 pounds of bananas. P equals 3. All right, questions, concerns on this second page? All right, so now this is like number 5 in our workbook, the hot air balloon. This one's a little bit different. A hot air balloon is at. So this is where it's at, right? But the balloon's altitude decreases. So that means we're actually going to be subtracting by 10 4/5 yards every minute. This is the one I told you to at least set up. So which equation can be used to determine the number of minutes it will take the balloon to reach an altitude of 57 yards. So we're setting it equal to 57. They all look like that. So we're starting here and subtracting this. So if we start here in both these places, but we're not adding that, we're subtracting that. So we would go with D here. We don't really have to worry about B here. You won't have anything that makes you deal with fractions. You're welcome. All right, so this one is like number 6 then. The current temperature is 48. It's expected to drop. So this is our starting. Remember, our starting is going to be our constant. And then we're subtracting this. Each tells us it's a rate. They want us to use H for hours. I'm teaching right now. You need to know this. You're taking a quiz this week. All right, so the temperature will be, so this is what we want it to equal. So we have 2 choices here. We're starting at 48, but then we need to subtract it because the temperature is dropping. These are nice when they are multiple choice, I feel like. So 48 minus 1.5 times the number of hours is equal to 36. So we are dealing with integers with these ones. If we subtract 48 from both sides, we end up with negative 1.5. H is equal to negative 12. Don't be afraid to use your calculator, right? You can literally put in 36 minus 48. And then we're dividing by negative 1.5. So I would show that in my work. Remember, you need to show both steps. It's a 2-step equation. Oh, I don't know why I put H here. Sorry. So we end up with H is equal to 8. how many hours? 8 hours. All right, I think we just have a couple more. Yes. This is how much they spent total on lunch. Their lunches cost the same amount. And they used a $4 off coupon. So 2 lunches, whatever they cost, and then they're subtracting $4 from it, equals this total here, 24.5. So this is a little bit backwards, but 24.5, those are all the same. We want 2C minus the $4 coupon, right? There's 2 lunches being purchased, her and her friend. So 2 times they told us the lunches cost the same, and they used the $4 off coupon, and it came to this total. So now we're taking the opposite, right? We've got to get rid of our constant first. So if I add 4 to both sides, I have 2C equals 28.50. So this tells us how much each meal costs. $14.25 before the coupon. All right. So you have the rest of this. Let's walk through it to be sure we can do them all. Oh, here's this answer, $14.25. Yeah, so number 10, you can do 11, you can do. I'm just trying to make sure there's no random fractions that are going to throw you off. So you don't have to worry about 15B. You should be able to do part A. All right, I think that's the only one. So you should be able to finish this. You've got 1, 2, 3, 4 pages. Tomorrow we'll be doing the review and going over it. So 6.1 through 6.3, this packet should be done. And any other practice, I would say, should be done by now because it helps you practice for the quiz.
Are we turning this all in on Thursday? Wednesday when we take the quiz?
Yep, Wednesday when you take the quiz, you'll use it for the quiz and then you'll turn it in. Yep. All right, so we'll review tomorrow. Make sure you're getting caught up. Make sure you're getting Alex done. You've got about 35 minutes still. No, that's not true. About 30 minutes still.